Pokemon style. Find them all. Cool. Anyone still going? Cool. I'm assuming you know what I meant. All zeros. Find all zeros. But it wasn't an equation. It was just an expression before. You can't solve an expression. You can solve equations.
Oh, we shouldn't have done anything.
You literally could have just said, can't, and sat here and laughed at me. But I'm guessing you all set it equal to 0 and ran with it.
Yeah, because then when you would have done that, then we would have had to do it. So.
Yeah. So, all right. If I have a polynomial, option 1, it is factorable. You got to do that little tricky trick. Does anyone want to do the tricky trick? Okay. No. God, you are definitive ractose. Just black, red, chaos right there. Okay. Most kids are going to say, I can do synthetic division. Theoretically, if you really, really, really wanted to, you would say all the factors of 12 over all the factors of 2. So 1, 2, 3, 4, 6, 12, and then all of that over 2. So 1/2, 2 halves, 3 halves, 4 halves. There you go. And then you would start guessing and checking those after doing Descartes' rule of signs to narrow them down to which positive, negative. But instead of doing all of that, because we live in the 21st century, I shall gaze into my crystal ball and say 2x to the 4th minus 5x to the 3rd plus 7x squared plus 2x minus 12. And I'll say, if I'm going to narrow down my options, I feel really lucky about -1. Maybe even a 3 halves. I just got a good feeling about them. So, I shall take the polynomial and rewrite coefficients only. 2, -5, 7 to -12. And say, boy, do I feel lucky about -1. And multiply, add, multiply, add, multiply, add, multiply, add. Yay, it works. And say, you know, I feel really lucky about 3 halves. And say, half of 2 is 1 times 3 is 3. Add them. Half of -4 is -2 times 3 is -6. Add them. Half of 8 is 4. 4 by 3 is 12. Add them. Yay, it works. But what do I got to do? Okay, before I move on, if I divided by 2 for my 0, I also have to divide by 2 here, getting 1, -2, 4, which is 1x squared minus 2x plus 4, which is not factorable, which does not even have real solutions. The whole point of this is take big polynomial and break it down to quadratic, because I know how to work with quadratics. And just to annoy you and show you that it's possible, because you're going to have to do it twice per problem when we hit chapter 7, I'm going to say x squared minus 2x is -4 and complete the square. I shall Half of b is -1. -1 squared is 1. I'll add 1 to both sides. Now I can write it as x minus 1, the quantity squared, is -3. I can solve by square roots. Square root both sides, getting x minus 1 is plus or minus square root of -3 is square root of 3i, or I squared of 3. Depends how you want to write it. Technically, it's supposed to be square root of 3i because it's a coefficient of I. But there's a lot of us who are going to write the I in front because otherwise it might look like the I is under the radical and then things start getting weird. And add 1 over to the other side. Getting x is -1, 3/2, and 1 plus or minus I root of 3. Yes?
Is it possible to have the square root of I?
Yes. There's an entire proof for it. Calculus. Although I have seen 1 or 2 Algebra 2 textbooks that have it. But you will use it in calc. Yep. So, did we? No. Bad. I would say, did ya? Did ya? However you did it, got your other 2 zeros, were you able to list them all, or did you just kind of forget and kind of peter out? Okay. So you got the work to show each of your real zeros. You got the work to show your imaginary zeros. Anything?
Is this how the actual quiz will look like?
Maybe.
Our daily quizzes?
Maybe.
It's a really stupid question. That's what our daily quiz looks like right now. No, like a regular quiz.
Well, you'll just have to look at the review.
It's like I get all this stuff and it makes sense.
Mm-hmm.
But then you throw words into it and it's like, oh, yeah, what are we gonna do?
I did not receive any questions that I can remember. We got anything?
When you were doing the ones that had like the upper and lower boundaries,
Uh-huh.
the upper boundary was like a lot further than what it looked on the.
No, it determine if it is a upper boundary. Your upper boundary can be, remember like the open circles, I'm not touching you, I'm not touching you? Your upper boundary, say the largest zero is at 6, you could say that 6.001 is an upper boundary and just do synthetic division with that. It would be gross, but at the end of it, you would have all positive numbers and it would show it's an upper boundary. Could I say that 10 is an upper boundary when 6 is my biggest zero? Yeah. Do I want to say 7 because it's the closest and the easiest number to work with? Yes. All of the above are true. It's just a upper boundary, not the upper boundary.
Well, it kind of is the upper boundary because every other number smaller than that was produced in negative numbers, except for on the calculator it didn't appear that way. I believe the upper boundary looked around to be 4.
No. When you
I'm just wondering why there was like just some ghost upper boundary of 7 when it didn't appear that way on the calculator. Because it wouldn't have worked any other way.
3 was the largest 0, and then we tried 4, and it still gave negative.
-13 in the second place after the on this one. Oh yeah, we did. Yeah.
Oh, the are you talking about the remainder at the end?
No, just in general, on 23.
It should have been positive, 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 negative. If the substituted value gets you a negative value on the graph. All right, let's just go find it.
Then it has like a negative in it. So the only one that works is
23. Okay. Y is 2x to the fourth minus 1, 13x cubed plus 21x squared plus 9x minus 27, double check. Okay. So I would plug in 5. Like if, okay, on 23, determine interval on which all real zeros of the function must lie. Explain your reasoning using the tests. Only real zeros. So I'm going to do function of -2, and I'm going to do the function of 4.
yeah, that's what's 5.
Really? Okay, -2 and 4. 2, -17. That is the wrong problem. -13, 21, 9, -27. -2. 17, 34, 55, -110, -101, positive. What are you talking about? Okay, so positive, negative, positive, negative, positive. Okay. And then 2, -13, 21, 9, -7, 27. 2, 8, Huh.
Yeah, the only one that works is
So the lowest one you could do that would be 7.
Huh. I don't know. I got to play with that. Like, I got to monkey around with it. I got to go double check the definition, maybe even crack open one of my old calc books. I don't know.
Did we get our brownie points from yesterday?
That was not intentional. I just forgot. I forget a lot of things. Yes, you did. Never mind the mysteries of the universe happening up here. Did I get my brownie points? I'm really interested to see what I gotta play with that. That's Yes.
So when you're doing like synthetic division and you divide by a fraction, so you only divide by the denominator?
Yes.
Okay.
Because
I've been dividing by the whole fraction and it still ends up working out.
oh no, it'll work. But at the very end of it, you might have like a 2 here instead of a 1. Meaning, like, take today's daily quiz. If you didn't divide by 2 there, what you're saying now is x plus 1 x minus 3 halves. And then, what was it, 1 plus or minus root of 3i, you know, imaginary roots, okay? If you don't divide by 2 back here, what you're effectively saying is that there's also a 2 out front of it in the linear factorization. And we're going to work more on that literally with the linear factorization of it on the last part of 2.4 that we didn't get to. Like, that's why it's important. Like, you can find the zeros of something, but it be the incorrect factorization of it, because it's possible that you get this. Like, this is what it's supposed to look like, but because you just flat out missed that 2, it was actually supposed to look like this. Like, your graph is twice as tall as it should have been. Or, no, half as tall because you missed the 2. There we go. Words are hard. So you can still have the same zeros, the same factorization, but one of them be twice as tall as the other because we just missed that. It comes more into play when we deal with our linear factorization and creating the polynomials. You say, when will I ever use this in real life? Because you're going to have to do partial fraction decomposition in calculus, and you have to get the full linear factorization to break something into all of its parts. You would be missing a 2 over thing. So, foundation here. This is like when you first start learning about proofs in geometry. Why would I need to learn how to prove something? Just friggin' look at it. Of course they're the same. You have to learn how to actually do the proof with the easy stuff so you can prove the hard stuff, which is every bit of math you'll ever do in college. So. Okay. If you want a associate's in culinary arts, you need college algebra and college stats. Every single associate's or higher degree at a minimum requires those 2. The majority of degrees only require those 2. If you're going into any STEM-related field, then you're going to have to keep going into Calc 1, 2, and 3, differential equations, and on and on and on and on. Okay. That should not be possible. Oh, no, okay, no. Surgical nurse, not surgeon. Okay, yes, you can do that. Whew. Scared to get the image of like LMA behind me looking something up in a book as my head skull is off. Like, okay, what do we got? Maddie had a moment. That is a true statement. Frank. Frank. Chill out, Frank. Okay, describe the possible real zeros. So stage 1. Okay, it says possible real zeros, not possible rational zeros. So this is just Descartes' theorem. So put in a positive x, negative, negative, positive, positive, negative. Sign change twice. 2 or 0 possible positive reals. Plug in a negative. Doesn't change, changes. Doesn't change, changes. I still see 2, so 2 or 0 possible negative reals. If it asks to describe all possible zeros, then I would also do the rational root theorem where I'd say plus or minus all the factors of 6 over all the factors of 3. No. Possible.
Yeah. You know, I didn't realize until this homework assignment that it said with examples.
Do you know that every textbook you have ever worked in has that?
Yeah, but our past, like my past teachers haven't done this where they like pull it from there. Like in words class, she didn't really have like certain things from it. She kind of just made it.
I want you to be able to look back at the example. So anyway, others? Okay. By popular demand, the review and the quiz are now on separate sheets. Before, I was just trying to not kill the earth. Now I've realized that this is merely a drop in the bucket compared to Bitcoin. So, have at it.
I think. Oh, so you're not giving us the postcard yet?
No, it's it is literally an issue of transference. And the more I've talked to kids, talked to some parents, that was just an issue that some kids were having. Transference is, I look at the problem on my quiz, I flip it over to look at the same problem on the review. I'm like, okay, that's the thing I got to do. I flip it back over, crap, I've already lost it. Okay, like that's called transference. It's your ability to pick something visually into your head and then to reapply it at a different location. And we have a tendency to goof things up, especially if your eyes cross a different number or problem along the way. That's when you end up randomly putting a 5 in where it didn't belong, because your eyes happen to cross a 5 on a different problem as you were flipping the paper over. So we shall do this instead. Okay. Also, fun fact, they're all gridded the same way so that you can fold them. So if you don't like having like paper next to paper, but there's numbers in between the two problems I'm looking at, it literally folds so that you can just have like number 1 next to number 1 with nothing around it. Unfold it, number 2 next to number 2 with nothing around it, so it's almost like a note card and a note card. So, like, that's why they're designed that way. So, no, do what you need to. I had a kid who handed in the daily quiz on a Starbucks cup wrapper before.
I'd do that.
So, hey Maddie, describe the possible real zeros, list the possible rational zeros, then solve. There's a reason that there's a little more space here, because it's going to be worth some more. You got a lot of stuff you have to do. Step 1, possible real zeros. If I say h of a positive x, count my sign changes. Positive, negative, negative, positive. I see 2 sign changes, therefore there are 2 or 0, remember it goes down in pairs, possible positive real zeros. If I plug in a negative x, y'all were cool with just the odds will change signs, the evens will not? I mean, if you want to actually plug the negative in there and do all of it, you can. I will have a negative, negative, positive, positive. I only see 1 sign change. So that tells me there's 1 possible negative real zero. The possible rational zeros is going to be all the factors of Q over all the factors of P. All the factors of your constant over all the factors of your leading coefficient. So?
Wait a minute. Our numbers are
numbers
different
is.
anyways. I just realized that.
Oh yeah. Everyone read it now. Everyone get answers.
Am I?
Yeah. Yeah, you definitely are.
Mine tells me. No, like the number.
That's the quiz.
He's doing the quiz.
He's doing the quiz.
You saw nothing. Why did it only... It only saved the one side of it.
I mean, the things were right though.
It was the exact same on the review.
Yeah, I know.
The answer was the exact same on the review.
Like what you had to do. You know, like
Hold on, hold on.
I was like, we were talking 20, and I was like, I know, I was like 15.
Whoa, I got 4 and 15. I was like, how did you get 20? It's the exact same.
It should not be. Hold on.
The signs. Yeah, the signs are the same. The sign changes.
The X is negative, but it makes them, yeah.
Okay. No, it for some reason it only saved one page as a PDF.
Did you want to see the review?
Oh no, I got it right here. It's just, that's weird. Well, freebie. There you go. That better?
Well, literally it's the exact same on the review.
Yeah, the same
The sign changes and everything in the same place.
Oh,
Yeah.
It was just different.
So it was just different stuff. So you just have to pretty much practice.
okay, so and then we're going to do our rational zeros, which is all the factors of, okay, so it's going to be plus or minus all the stuff of 15, 1, 3, 5, and 15. All the factors of 4, 1, 2, and 4. You cannot leave it like that. Is plus or minus all that stuff over 1. All that stuff over 2. 1 half, 3 halves, 5 halves, 15 halves. All that stuff over 4. 1 fourth, 3 fourths, 5 fourths, 15 fourths. Whew! And that is your possible rational zeros. Now it does say to solve. I see 12, 24 different things to try, and 2/3 of them are fractions. I'm guessing you don't want to guess and check a bunch of fractions. So, what number do you feel really good about trying?
I don't know yet. I gotta think. Alright, I'm feeling pretty good about 1.
You're feeling pretty good about 1? Okay, let's try 1. We'll say 4, negative 4, negative 4, negative 15, negative 15. Skadoosh. Hey, it worked. Good job. But then, this is a quadratic, x squared minus 4x minus 15. Last I checked, there were no factors of negative 15 that add up to negative 4. So,
Like the first one should be 4 instead of 1. Oh. Makes me feel better.
okay, so are there factors of negative 60 that add up to 4? Yeah, there are. This is factorable, which means there should be more rational zeros.
I'm pretty good about 5 halves. Yeah, 3 halves is pretty good too.
Okay. So, okay, once you hit quadratic, you could go with the quadratic formula, complete the square, you can factor it, or you can just keep going if you are really good at guessing. You said what, 5 halves? So half of 4 is 2. 2 by 5 is 10. Add them. Half of 6 is 3. 3 by 5 is 15. Yay, add them. I'm going to call that instead 2 and 3. And then I'll feel really, really good about 3 halves. Negative 3 halves. So drop it, little hot, and say half of 2 is 1 by negative 3 is negative 3. Oh, hey, look at that. And then, to finish it completely off, also divide that. So, describe the possible real zeros. Descartes' theorem. Okay, put in positive x, put in negative x, count your sign changes, and it always goes down in pairs. Possible rational zeros. That's where you're going to put all the factors of q over all the factors of p, and then you list them out. Don't just write this and quit. Okay, list them out. And then actually find which ones they are by guessing really well. Have the work to back it up. Don't just write, those are my zeros, and quit. You have to have the work to back it up. Because if we're going to cheat smart. Okay? Don't cheat stupid. Well, I mean, are you finding the zeros? Do you have the work to prove that they are the zeros? Instead of just, I looked at a calculator.
We're not really cheating. We're just using our resources.
Yes. This is the thin gray line between using my resources and just not doing the problem. This is the line. Now you notice you had to do a boatload of stuff right there?
Yeah,
that one's going to be a lot. Okay. Oh no, that's more than, this is not broken up evenly. These are probably going to be 5, 5, and 5. And then I'm thinking it's going to be like 8 and 7. Because of how many things we had to do. Okay. Write a polynomial function of least degree with integer coefficients that has zeros. If I have this as a 0, I know this is the linear factor that made it. Do you really want to do that with its conjugate, and then that with its conjugate? You can go distribution bonkers on that, or handy dandy cheater that says x squared minus 2ax plus a squared. Now for this one, is it plus or minus between the a squared and the b squared? Minus, because I won't have that I squared to change my signs. Or for this one, it's x squared minus 2ax plus a squared plus b squared. And I will plug in my a and b for each of these. A is 2. B is the entire radical square root of 3. That's also true if it's uglier. If that was 2 square root of 3, an entire 2 square root of 3 goes in there, not just the square root of 3 part. Okay, the entirety of the radical. A. What is B? Just the negative 5. Okay, not 5i. The I is taken care of in the formula. Ask it, because that was a lot of thinking, and I want to know like what you just eliminated.
Because I was thinking like with I thought it went negative minus 1. I thought you flipped it, and then I realized that
Okay. Technically, you can use this formula all the time, if you put the I in with it. But then you start getting into, you're not actually putting in B, you're putting in BI. And it starts to muddy the definition. So I'm cool with just having two different cheaters. But it is a -5. Okay. So first one, x squared minus 4x. 4 minus 3. X squared minus 8x. 16 plus 25. And then distribution bunkers. X squared times all the stuff is x to the 4th minus 8x to the 3rd plus 31 x squared. -4x. What? 16 and 25 is, yeah, it's 41. No, hate's a really strong word and it has to be worth it. No, if you're going to hate something, it has to be worth the energy to hate it. There's only like 4 people in the world that I hate, and one of them's dead, so. Okay. So, -4x times all the stuff is a -4x cubed, a positive 32x squared, and a -164x. Take a 1 times all the stuff, get x squared minus 8x plus 41. At the end of the rainbow, finally, f of x is x to the 4th minus 12x to the 3rd. I can count, right? Okay. 4, 7, and minus 172x plus 41. Okay. I get all the way here. How do I know I'm right? This is why we had to review long division, not just synthetic. And this is what we're going to do in the back half of 2.4, is you have to take this divided by this, and you'll get that. Okay? So that was one of our last examples we didn't get to. You don't have to do it here. That's why it's not required on your quiz, because we didn't get to it. But one of our last examples is, how do you find the other zeros if you know these ugly ones? So you take the whole polynomial and divide it by the quadratic that made ugly zeros to get remaining polynomial. Okay? But no, you just have to multiply and get here. I don't care which way you do it. If you want to do the cheater, if you want to do it manually. Most kids are going to choose the cheater. But again, the cheater is nowhere in any textbook that I've ever seen. But every Algebra 2 teacher that I've talked to shows their kids that. So. Okay, next up. So these are kind of out of order here. Those were just big because there was a lot of stuff. Back to 2.2, find the function's end behavior with limits, possible number of zeros, number of possible zeros, number of possible real zeros, and turning points. Then the graph the function. Boy, it's been a week. Labeling the, there we go, extrema. Yourself. Hey, before I even start putting something on here, I already know what its end behavior is, right? Positive, even. It's my leading term test. So since I have a positive x to the even as the leading term of my polynomial, I know the limit of my function as x approaches both positive and negative infinity is infinity. No, we don't use that language here. Okay. Very T'Challa meme. We don't do that here. Okay. Yeah. Actually, that's kind of what my kid does. He just like runs up to you, headbutts you in the junk, and then goes, ah. So, all right. What's the number of possible real zeros? How do I know it's 4? Degree 4, okay. Possible real zeros is 4. That means the possible turning points is always 1 less than that, yes. Okay. Go find some zeros in extrema. So we're going to dump it in our calculator and start pressing buttons. Y is clear. 3x to the 4th minus 5x to the 3rd plus 2x squared minus x minus 2 graph of a. Okay. Remember the days of Frank and his ex back here? Yeah. So, okay. So, just to double check things, I'm going to look for those zeros, -1 to 0. I want to know if those are rational or not. Nope, they're not. Okay, it doesn't say specifically to list the zeros, so I don't have to because loophole. But I should probably have my y-intercept of 0, -2. Right? If I put a 0 in for x, I got that -2 hanging out at the end of the problem. So really all I need to do is determine what this is, and I'll call it an absolute minimum at approximately, and we're going to go out 3 places. I don't care what it looks like. I want to know what it really is. Second, calculate a minimum somewhere between 0 and 6, because why not? Huh. All right. Feel like I should have like the little Maui tattoo right there. The dude like, ding, Mariah won. Okay. So when I go to graph this, I need to label, there's my absolute minimum at -1 or +1, -3. This was at about a half. This was at about 1.5. I had my y-intercept at 0, -2, and we're just going to kind of wing it with the kink right there. Okay. But if you want to double check stuff, you can always actually list your zeros. Okay. Because it does say possible zeros, possible turning points, graph the function, labeling the extrema. Because I did not put to label the zeros on there. Loophole, you don't have to. Just try to make sure they're in about the same spot. Okay. It says divide. It doesn't say how. I don't know too many people in here who are going to choose long division. Go for it. Okay. Who already missed it? What's something that we should be writing next to this problem?
Don't forget to
Look for Missing terms. Look for 0 as a placeholder. Okay, otherwise it will completely wreck your answer. All right, what am I dividing by here? What's my 0? 2/3. That also means when I get to the end of this, now I have to divide my answer by 3. Okay, so drop it, little hot, and say 1/3 of 27 is 9. 9 by 2 is 18. Adam. 1/3 of 18 is 6. 6 by 2 is 12. Adam. 1/3 of -6 is -2 times 2 is -4. Add them. 1/3 of 24 is 8. 8 by 2 is 16. And remember, some books like to have that like little dividing line there, separating out your remainder. Now, I need to also divide this row by 3 because I turned, when I did 3x minus 2 equals 0, I divided by 3. So if I divided by 3 there, I have to divide by 3 here and call it 9x to the what? Cubed, because I took a quartic and divided it by x to the first. So 9x to the third plus, divided by 3, 6x squared divided by 3 minus 2x divided by 3 plus 8. What do I do with my remainder? Okay, plus 2 over 3x minus 2. And because I'm leaving the 3 right there, I don't touch this 2. Now, if I put it over x minus 2/3, then I would have to take this part times 3, right? So, like, you got to be careful with it. Most of us seem to prefer dividing this line by 3 instead. Now, if you do this by long division, you don't have to remember that at all. It just takes care of itself. So, trade-off, right? Trade-off. Womp womp. Okay, apply the leading term test for end behavior. So we're going to do it again. So the limit of my function as x approaches. How do I know what the leading term test is if it's, or the leading term is if it's in factored form? I'm going to take an x times an x times an x times an x at the beginning of my problem. So I'm going to have a positive 1x to the fourth. So it's a positive even. So just like the last one, as I go to both positive and negative infinity, this is going to infinity. So we know we're going to be up here. I just don't know what else happens in between. Find the zeros. X is -4. If you want to use that little chemistry style bastardized hybrid notation over there, go for it. That is not official, that's just me. Officially, you're supposed to write multiplicity of 2 in parentheses. And a -1 and a 2. So at -1, womp. At 2, womp. At -4, womp. I know that it's going to, because it starts at positive infinity, it's going to come down to the -4 and bounce off like a parabola. It's going to have to come back down and go through -1 like a line. And then it's going to have to, because it ends at positive infinity, go up like a line through 2. Because it happened 2, 1, and 1 times. The degree or the multiplicity of each determines the behavior at that 0. So I know that it's going to do something like this. But I'm not sure about those. Well, actually, 4 times 4 times 1 times -2. If my leading term is going to be x to the 4th, I know at the end I'm going to have a -32. So I know my y-intercept is like down there. So go find your extrema. Type it in the calculator, find your extrema. X plus 4 squared, x plus 1, x minus 2. Calculate a minimum. Whew! Do they hang low? Somewhere between -1 and 2. It's a song. Do your ears hang low? Do they wobble to and fro?
That's what my Algebra 1 teacher made our quadratic formula song to. Then my dad told me what the song was. Yeah.
Now there are different renditions of that song.
Yeah. I was scarred. I was an 8th grader.
So we got to go all the way down to -50-ish. So I'm going to say by 2. Okay, y'all. Don't put that on your graph.
I would be that person.
Don't put that on your graph. Or be the kid that just goes, no, bad. Okay? I'm going to go by 5 so I can actually fit at -50-ish. So, and I'm going to say approximately 0.921 -50.194. I even said by 5s and then I wrote by 2. Wow. See, when you, yeah, A, executive dysfunction. It's literally a thing. B, I got hit in the head a lot in high school. So, what about my maximum? Who got it?
-2.179, 16.338.
2 point. Okay. And then connect the dots. Okay. So, y'all really have no idea the combination between school and home. What a roller coaster the last 3 weeks have been. Thanks for hanging in with me. Devices over there. Get up, scramble yourselves around. Don't sit next to someone you normally sit next to, or you know that I'm going to say, nah. Okay? Get up, mix yourselves around. Yes! Well, there you go. Anna's getting, one of you, come on. 2 of you.
Oh, really? I like my spot. Yeah, there we go.
I'm waiting in. You're wasting time.
Guys, we only got like 20 sentences left. You're like, hurry up.
You might have to do it again.
Which is usually where I time these tests at.
20 sentences? I'm pretty fast.
What if we don't?
Fix it. Yeah, you're far enough apart. You move down. No one's coming in to observe.
How do you know Mr. Gillette is walking right now?
Because usually if we're taking a test, they just keep walking. I'm waiting.
For what?
No. Bad.
He's saying that you guys
Can we take
Yeah, same. One of you two go.
can we take your chair?
What?
Can we take your chair?
No. Mine. Better. And when I told you that what happened before was not my norm, I do indeed mean it. I already gave. No, I didn't. Yesterday, Algebra 2 took their quiz. They're already done. So these will not take forever like before.